Hi, once again, my name is Debora Osafo, and this summer I'm working at State College, and my mentor is Barbara Zach. The title of the presentation is Modular Synthesis of Fluorinated Molecules. Abstract. So fluorine acts as an attractive substance for biology structural studies. And the use of fluorine has increased the study of environmental pollutants at molecules level. So the class of compounds constituted by polycyclic aromatic hydrocarbons, which is PAH, can be fluorinated at various sites for the net biological results. So the aim of my research is to obtain a net analysis to understand alteration of fluorine substitution. And I'll explain this later as we go. Introduction. So what is fluorine? Fluorine is a stabilized type of element found on the periodic table, and it has an atomic number of 9, and it can be found on the second row element of group 17. Fluorine is a very light element among the halogens on the periodic table. Its standard atomic weight is 18.9984 calmol, and its electric configuration 1s. 1s, 2s, you guys will know this later. We'll also, as for its stellium properties, it has a very high electronegativity, which is 3.98 on Pauling scaling. It has a very small van der Waals radius, and it has a very low polarizability. It can tightly bond three non-bonding pairs of electrons, and it has a higher probability that overlaps between 2s and 2p orbitals of fluorine and the corresponding orbitals of the second pair. What are fluorocarbons? Fluorocarbons are organic materials that contain fluorine. Generally, carbon is bonded with hydrogen. And when carbon is bonded with hydrogen, its energy bond is 99 calmol. In my studies, what I'm doing in the chemistry lab, my mentor's lab is they transport, okay, I'll get there. But when carbon is bonded with fluorine, the energy bond is 116 calmol. And this pretty much means that the energy bond between carbon and fluorine is much greater and it's very stabilized. Fluorine substitution. When fluorine is substituted, it changes properties of when fluorine is substituted, it changes properties of biologically active compounds. It affects the hydrophobicity and the lipophilicity of compounds. It influences the metabolism and distribution of drugs and molecules in the body, and then it changes the molecular conformation. Some applications of fluorinated carbons. Fluorine is many products actually made contain many products that you guys use or daily and everywhere contain fluorine. That's particularly in drugs. Over 150 drugs may contain fluorine, and these are examples of some of the medications that contain fluorine. Antiacids, anti-inflammatory, modulatory of cholesterol metabolism, antidepressant medications, antiviral, antibiotics, antimalarial, triazole, antifungal. As you can see in all these compounds, it has fluorine in them. And also, in agriculture-wise, some other products such as herbicides, insecticides, and fungi also have fluorine in them. And also in polymer industry, such as Teflon. You guys may know what Teflon is. For example, like all the commercials, there's for those who like to cook, there's like a spray that when you spray the pan, it makes your food non-stick. The pan, that also includes Teflon. And also gaseous substance has fluorine in it. Chemical reagents such as triglyceric acids and trifluoroacetic acids also has sulfone in it. So pretty much what goes on in my lab is that we obtain sodium salt hydroxyl sulfide, which is this, and we react it with alkene, which is this group. So when we react it with this alkene, it gives us, sulfone. This sulfone is then oxidized. This sulfone is then oxidized in, excuse me. Okay, so we take sodium of hydroxyl and react it with alkene. This alkene then gives us sulfone. We subsidize this sulfone. This is sulfide. This oxides to give us sulfone. This sulfone is then fluorinated at alpha position. At this position, we apply a method called Julia alternation. This Julia alternation is pretty much to give us a compound or to give us a product that has alternations and pretty much this is a basic method of what goes in my chemistry lab. Because my the chem group in our reflex lab are working on getting a treatment to cure cancer. So right now they're not there yet, but what really goes on is just create compounds and get products that can be used to take into further biological tests. And these are one of the methods that they follow to obtain such compounds. I haven't done much yet, and this is just some of the basics that I had to learn. And for example, say on the sulfone, which I showed earlier, this sulfone has an R group, and as I explained in my introduction, that when carbon is bonding to a fluorine, its energy bond is greater. So they obtain a compound. It can be sulfone, which is an R group, and sulfone, this R group is like a variable. You can substitute with fluorine, bromine, chloride, anything. So when you substitute F with fluorine, as they obtain a sulfone here and substitute certain. So when you substitute that for this X, it gives us fluoroalkane. If it was to be substituted by hydrogen, it would give us alkenes, but that's not what we want. We want to obtain fluoroalkanes. And this is like a description of what goes on. And this is just, as I said, a general kind of lab techniques, works that are going to be used to develop a product to say probiotic test. I haven't done much at all, but so far, variations of R group can give, as I was saying, variation of R group can give a library of fluoroalkanes, which is what we want to take to look further study for cancer research, for cancer treatment, and also so keeping this in mind, R group, which will choose currently to generate a new variety of alkanes, is very, very essential for these. So far, what I have just learned is the basic lab techniques, such as thin layer chromatography, column chromatography, and extraction, solvent extraction. So that is it for today. I need some references. Acknowledgement. I would thank all people that wrote that. My mentor and the co-mentor which I work with are Keish, and the chemistry department, my teachers, my school, and my former mentor. And that's it.